Hey guys, Stat 1800. Now again, this is fall 2017 that I'm posting this video. So if you're taking this class in another semester, just make the obvious changes. Something I want to show you. What the purpose of this video is last week, or at least I should say the last few videos, we've been looking at numerical summaries. And I think it's a good time to kind of step back from that and just work some problems from the book. So what you can do, if you come down to Multimedia eText, we are currently in Chapter 3. And over here, we can look at some chapter review problems. So if I click that, it's going to go through some stuff. I have to update my Flash player, but anyway, well, actually, it's working a little faster than usual. All right, so I'd already opened it up here because I thought that if my internet wasn't working well, that I'd already have it up for you. But anyway, what I want to look at is problems 3.69, 3.72, and 3.73. So you can see I need to go to the next page. So I click this button. And again, I'm searching for 3.69, which is oddly about download speeds. So again, I want to look at 3.69, 3.72, and 3.73 as a review on the things that we've been studying in the last 6 or 7 videos. So now you can say, you can see, have you ever wondered about internet download speeds vary around the globe? The file download speed contains a mean download speed for various countries, data from this website. So it wants us to do the standard stuff. Calculate the measures of central tendency, the mean and the median, and then get into some measures of variability, quartiles, variance, standard deviation, coefficient of determination. Now, what we want to do is we want to go back to our main menu. We want to open up StatCrunch. And I want to look at data sets from your textbook. And the data set that I want to look at comes from Chapter 3. And it is download speed. So there it is right there. So I'm going to click it. It's going to put it into StatCrunch, which is really cool. And you can see that it's already sorted the data. In other words, it has the download speeds in descending order. So I feel like I would be way down here. Let's just see the countries that have the lowest download speed. Afghanistan, Cuba, Algeria, Bolivia, Venezuela have very, very poor download speeds. I'm curious. I go to Mexico a lot scuba diving, so I'm not really impressed at all with their download speeds. So. Well, anyway, look at the best download speeds across the world. You get into Hong Kong, Singapore, Romania, South Korea, a lot of Asian countries, Sweden, Netherlands. So anyway, the purpose of this problem is to examine the download speed. So first of all, it says compute the mean, median, first quartile, and third quartile. So guys, we should be really good at that by now. We go to Stat and go to Summary Statistics and go to Columns. So we want download speed. And my cat is losing his mind. Well, actually, it's not my cat. It's my daughter's cats. So I want the mean. And I want the, what do we have, median. And we want Q1 in Q3. So very easy stuff. It used to be back in the old days we had to do this by hand, and it wasn't so fun. So we can see that we have a mean of 12.11, 12.12 rounded to the hundredths. Median is 7.39, Q1 4.05, and Q3 15.92. Now what does this tell us? When I look at this, with my background in statistics, what I look at, well, first of all, I see that the mean is significant, quite a bit higher than the median. So that indicates to me that we have a positively skewed distribution, because a positively skewed distribution has a mean bigger than the median. If the mean is smaller than the median, we have a negatively skewed distribution. If the mean and the median are equal, we have a symmetric distribution. When I look at Q1, I see 4.05. What I think about on this measure is approximately 25% of countries have download speeds less than 4.05. When I look at Q3, 15.92, I think approximately 75% of countries have download speeds less than 15.92. All right, I'm going to close that down. The next questions are find the following stuff. So we need to find the range. So the IQR, the range, the variance, the standard deviation, and the coefficient of variation. All right, so hit compute. IQR 11.87. This tells me that the range of the middle 50% of our data is about 11.9. The range is the difference from the highest to the low, so that's about 71 difference. Variance and standard deviation, coefficient of variation are just measures of variation. Okay, the second thing, construct a box plot. Are the data skewed? So when I do a box plot, I want to use fences to identify outliers, and I don't really care about horizontal or vertical. Yeah, whatever. I usually draw horizontal just because I do. So clearly when we get this box plot, we can see that we have a right tail. Now look from the top 25%, and we can see that we have download speeds that are outliers. All of these isolated points are outliers, so we have a lot of outliers in our data set. But the upper 75% of our the upper 25% of our distribution has that much spread from here to here. I hope you can see my marker. Where the lower 25% of spread is just that much. About the same as the second 25%. The third 25% is a little bit more. The fourth 25%, which goes from all the way here out to there, is quite a bit more. So we have a positively skewed distribution. And these countries right here, country number 1, Hong Kong, country number 2, Singapore, country 3, Romania, are outliers compared to the other download speeds in other countries. So finally, based on, this is part D, based on the results of A through C, what conclusions can you reach concerning, well, I'm reading the wrong one. Hold on. Guess I've lost my mind. Okay, 3.69D. Based on the results of A through C, what conclusions can you reach concerning the download speeds around the globe? Well, exactly what I said previously. I can go through each of these measures, the mean, the median, the quartiles, and make the statements I made earlier, but we have a positively skewed distribution with about 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, about 13 countries that are outliers. The median would be the best measure of center for this distribution because it's so severely skewed. So the median of 7.39 tells me that about half the countries have download speeds below 7.39. About 50% of the countries have download speeds above 7.39. The slowest is 0.94. The upper is 33. No, wait a minute, what's going on here? Oh, that's just for the inner quartile there. Obviously, the upper is 72.07. All right, gang, let's go on and look at the next problem, 3.72. So I'm going to close this down. 3.72 deals with credit scores, and pretty much it asks the same types of questions, so we'll run through those very quickly. So it's under credit scores, so I'm going to go back. I'm going to open up credit scores. And it's got city and state, and then it's got average credit scores. So doesn't look so good for Texas, Mississippi, Texas, some of the southern states. And the highest credit scores, just on glance, Wisconsin, Minnesota, Iowa, California. So make of that whatever you may. So, guys, same game. Let's go through summary stats columns, average credit score, and what we want is the mean, the median, Q1 and Q3. So we can say that the average credit score is 746.22. The median is 749. So half of the credit scores are above 749. Half are below 749. Q1 730. 25% of the credit scores are at 730 or below. Q3 763. We can say that 75% of the credit scores are at 763 or below. Now that you're an expert on credit scores. All right, so part B, we want to take a look at the variance, the standard deviation, the range, the IQR, and it looks like the coefficient of variation. I'm not a big fan of the coefficient of variation. It's not something that I report when I'm reporting things for publication, but whatever. So the range 89, that's the difference between the highest credit score and the lowest credit score. IQR of 33, that's the range of the Q3 minus Q1. All right, gang, it wants us now to take a look at a box plot, so let's do that. And I'm just going to go with the same settings. I want to display outliers if there are any, and I'm going to do a horizontal box plot. So guys, we have a symmetric distribution here. The upper tail and the lower tail are very similar. Okay, and there are no outliers. So part D, based on the results of A through C, what conclusions might you reach concerning the average credit scores for American cities? The distribution is symmetric, so I would focus on the mean and the standard deviation as the measure of center and spread, whereas in the previous, with the download speeds, what was severely skewed, I would report it all, mean, median, and standard deviation, quartiles, and all. But I would focus on, as a measure of center, I would look at the median, and as a measure of spread, I would look at Q1, Q3, and the IQR. So depending on the type of distribution we have, that's the measure of center and spread that we focus on to draw conclusions. All right? Now, 3.73, I want to bring this up, and I want to get in on that. I want to make that a little larger so you guys can for sure see it. So 3.73 says you are planning to study for your statistics exam with a group of classmates, one of whom you particularly want to impress. The individual has volunteered to use Microsoft Excel. He or she is not taking my class because we use StatCrunch to generate the needed summary information tables, charts, so on and so forth. The person comes over to you and with the printout and exclaims, "I've got it all, means, medians, and so on and so forth, for all of our variables." The problem is some of the outputs look weird, like box plots for gender and for major and the pie charts for grade point average and for height. Also, I can't understand why Professor, last name I can't pronounce, said we get the descriptive stats for some of the variables. I got them for everything. See, the mean for height is 68.23 3, the mean, and so on. So what is your reply? Well, your reply is this person doesn't know what they're doing. First of all, they're not appreciating just fundamentally the difference between quantitative data and categorical data. For example, the last sentence, well, next to last sentence, the mean height is 68.23. That's fine, because that's a quantitative variable. The mean grade point average is 2.76. That's fine. GPA is quantitative. The mean for gender is 1.5. It's a stupid statement. Gender is categorical. How do you add M plus F plus M and divide by 3? Well, if you know what you're doing, you don't do that. So mean isn't appropriate for gender because it's categorical. The mean for major is 4.33. Again, a stupid statement. Major is categorical. When we look at summary statements for gender and major, what do? We look at frequencies and percentages. We don't look at means because they're not quantitative variables. And the same thing can be said up in the body of some of the other narrative of this question, 3.73. It says they like box plots for gender. Well, box plots are for quantitative variables. Pie charts for GPA and for height. Guys, pie charts are a way that we display categorical variables. You don't use pie charts for GPA and for height because they're quantitative. All right, well, guys, that's all I got in this video. I think it's worthwhile to step back. There was a lot of information thrown at you, recently. So I think it's good to step back with problems like this and just kind of get a summary of what I wanted you to learn. All right, so take care.